Hi, welcome. Today we are going to look at probability, okay? And at the end of this lesson, you should know what probability is. You should know how to use the addition rule and the multiplication rule of addition, and you should also know conditional probability. Okay. So before I start, I want to tell you something brief about probability. Okay. So kindly listen and kindly pay attention. Now, when we say probability, what does it mean? Simply put, okay, probability is a value between 0 and 1 inclusive, meaning 1 is part and 0 2 is part. Inclusive, it should be between 0 and 1, okay, describing the relative possibility or chance of an event occurring, okay. So that's what we call probability. Are you getting it? And it is important for you to know, say, probability cannot be more than 1, okay, and cannot be less than 0. If something is less than 0, it means the thing is negative. So you can't get a probability to be negative answer. It will surely be between 0 and 1. And it cannot be greater than 1. It can be 1 point something, 1.5, 1.2. No. Okay, so it's important to know that as well. Now, before I enter, I'm going to be using questions and answers to explain the entire topic to you, because this is not the first time you are meeting probability, which I'm sure of. So I want to tell you the meaning of certain terms in probability, because it can be asked in MCQs. So the first term you are going to look at is outcome. When we talk about outcome, what does it mean? When we say outcome, it means that a particular result of an experiment is known as outcome. Okay. When you do an experiment, the result you get from that experiment is known as what? Outcome. Let's say you toss a coin once. If the result of that coin, okay, the tossing of that coin, if the result is, let's say, a head, then that head you've got is the outcome of the tossing you've done. Okay. The result you've got is the outcome of the tossing you've done. Now there's something we also call events. Okay, event is a collection of one or more outcomes of an experiment. So when you collect one or more outcomes of an experiment, it's called event. Okay, then a single performance of an experiment is known as trial. Okay, a single performance of an experiment is known as what? Trial. Okay, trial. So if you toss a coin 5 times, meaning you've tried it 5 times. Okay. So it's important to know that as well. Now, without wasting much time, let us proceed. As we go along, I'll be telling you some more things about that. So let's take the first question. Now, before we answer this question, now, we have two approaches to probability. Okay, we have the objective approach and we have the subjective approach. Hello, we have the what? Objective approach and the subjective approach. Now, what do we mean by this? For the objective approach, it is further divided into two. Are you following? The objective approach is further divided into two. The first one is known as the classical approach, and the second one is known as the frequentist, the relative frequencies, or we call it empirical. Okay, please take note of that. The objective approach is divided into two. The first one is the classical, and the second one is the what? Is the empirical. For the classical, they say probability of an event occurring is equal to the number of that event divided by sample space. So if you toss a coin, let me give an example. If you toss a coin once, what is the probability of getting a head? How many heads are in tossing a coin once? There is only one head, so 1, the number of that event, over sample space. There are 2 sample space. You get a head or a tail. You get it? So that's what they say. But the frequentist approach, we use it for large numbers at times, and they construct data. I'll show you when we go forward. I have a question on that. Now, let's look at the question. This question says, two people X and Y applied for a job in a company. The probability of selection of X is 2/5 and Y is 4/7. What is the probability that both of them get selected? Now, before you answer this question, you should know this multiplication rule. You are going to use multiplication over here. They said both of them get selected, meaning X and Y got selected. That's the meaning. If I say X or Y get selected, it means it's not both of them, it's either of them, it's one of them. If I say X or Y, if I say get me shawarma or wache, it means get either of them for me, it's not the two of them. But if I say get me shawarma and wache, it means I want the two of them. Are you following? Get me shawarma and wache, it means I want the two of them. If I say get me either shawarma or wache, it means either of them, one of them. So this is both. So both means and in probability, when we say and, A-N-D, and is trying to talk about multiplication, or is trying to talk about addition. So when you see or means addition, and means multiplication. So both means and also means what? Multiplication. So we are going to use the multiplication rule. Are you following? So for the multiplication rule, please pay attention. For the multiplication rule, we have two formulas depending on how the question looks. Let's say probability of A and B intersection B, okay, A and B intersection is also and, should be equal to probability of A plus probability of B, sorry, I'm really sorry, times, I'm really sorry, forgive me, probability of A times probability of B given A. B given that A has already occurred. Given A. Another formula says that probability of A and B, A intersection B, should be equal to probability of A times probability of B, just like that. Probability of B. Now, the first one is used if the events are dependent events, okay? The first one is used if they are dependent events. And this one is used if they are independent. Now, X being selected or Y being selected does not depend on any of them. It's not stated in the question, okay? Nothing like that shows. So to get a probability that both of them get selected, it means X got selected and what? And Y got selected. So that's times. X got selected times Y, probability that Y got selected. Do you get it? So what's the probability that X got selected? 2 over what? 2/5, isn't it? Times what's the probability that Y got selected? 4/7. So 2/5 times 4/7 should give you what? 8/25. So the correct answer for this is C. Is that clear? Let's proceed. In a class, 30% of the students study French. So meaning, I want you to know that probability can be given in percentage form or in decimal form. So in a class, 30% of the students study French, meaning probability of those who study French is 30%, which is 30/100. Probability of French is 30%, which is 30/100. Are you following? 30% means 30/100. Do you get it? Then 45% study maths, meaning probability of those who study maths is what? Is 45%, which is 45/100. 45/100. Then 15% study both French and maths, meaning probability of what? French intersection maths, French and maths, okay? French intersection maths. Intersection means when you do the two together. It's 15/100. Hello? Now, and the question says, what is the probability that he or she study French or maths? Look at this or over here, French or math. In probability, if you hear or, I want you to use the addition rule. Now pay attention. For the addition rule, we have two. Okay, I'll tell you the difference between them. Probability of A, addition rule states that probability of A or B, okay, or can also be union, okay, A union B or A or B should be equal to probability of A, are you following? Probability of A plus probability of B occurring, are you following? Probability of B minus probability of, that's what the addition rule states to, minus probability of A intersection B. Probability of A or B, A union B is equal to probability of A plus probability of B minus probability of A intersection B. And the second formula says that probability of A or B, I'll tell you when and when not to use either of them. Probability of A or B should be equal to probability of A occurring plus probability of B occurring. I hope you are following. You can use this to answer every question if you understand. Now, look at this is used. Please pay attention. This is used when the events are non-exclusive events, meaning two things can occur at the same time in that event. Okay, so for this question, we are going to use the first one because there are situations where some people study French and maths together. So we are going to use this one for this question. But this is used when the events are mutually exclusive events. Now, somebody will ask me, what is mutually exclusive events? Mutually exclusive events are events that cannot occur simultaneously, like being a boy and a girl. Can you be a boy and a girl at the same time? No. You see that? So they are mutually exclusive events. But you can read French and maths at the same time. Even in this question, it is telling you that there are some people who read both French and maths. So if something can happen simultaneously, if people are reading both French and maths simultaneously, then they are called non-exclusive events. So F and M, French and maths, are non-exclusive events in this question. Okay, they are non-exclusive. But if there is a case where nobody is allowed to do two things together or to be two things together, it is called mutually exclusive events. Hello. You cannot have two blood groups together. You cannot be blood group O and blood group A together. So since you can be blood group O and A simultaneously, they are also mutually exclusive events. So, but for this question, it is non-exclusive. So we are going to use the first formula. The first formula is called a general addition rule, and the second one is called a specific rule. Okay, it is only used when there is no intersection. Okay, when there is no joint like this one. So for this, since they are non-exclusive, and we are going to use this. So probability of French plus probability of maths minus probability of French intersection maths. That's what you do. Okay, so probability of French plus this minus intersection. So 21 over 100, is it 21? 30 over 100, 30 over 100 plus 45 over 100 minus 15 over 100. Use your calculator. You get 60 over 100, which is 6 over 10. And it can be minimized towards 3 over 5. When you use your calculator, you get the answer straight. Okay, so let's go to the next one. In a box, there are 8 oranges. There are 8 orange, 7 white, and 6 blue balls. Meaning in a box, there are balls, okay, and 8 of them are orange color. This orange is not fruit, okay, like the color. 7 white and 6 blue, okay. 6 are blue. Now, if a ball is picked up randomly, what is the probability that it is neither orange nor blue? Please pay attention to something here. Neither, meaning it is not. Okay, neither nor. It means both. It is not orange and it is not blue as well. Okay. Now, to answer this question properly, first let's know the total number of balls. So total number of balls will be what? 7. So total number of balls okay, will be what? 8 plus 7, 15 plus 6, that's 21. So total number of balls is 21. Now, what is the probability of selecting orange? What would be the probability of orange ball? Just let's jot them down first. Probability of selecting an orange ball, picking an orange ball will be 8 over what? Over 21, isn't it? That's number of balls that are orange over total number of balls, isn't it? What's the probability of selecting a white ball? The probability of selecting a white ball should be what? 7 over 21, isn't it? 7 over 21. You have to know that. The probability of selecting a blue ball, should be what? Number of blue balls, which is 6 over what? Total number of balls, 21. But that's not what the question is. The question says, what is the probability that it is neither orange nor blue? Meaning, what's the probability that it is not orange and it is not blue? If something is not, there are 3 colors there. If you are saying it is not orange nor blue, then it means it is white. So meaning you should find a probability that it is white. And the probability that it is white is what? 7 over 21. And 7 over 21 can also be simplified further to give you 1 over 3. If you use your calculator. So the answer for this is 1 over 3. Is that clear? Another way of doing it is, it said neither orange nor blue. In each positive tense, it should be either orange or blue, isn't it? So how do you find orange or blue? You add them, right? Orange or blue. So orange is what? 8 over 21. Or, that's plus, blue, which is 6 over 21. Here you won't subtract any intersection because there's no situation where some balls are orange at the same time blue. Do you get it? So that gives you what? 14 over 21. Now 14 over 21 gives you what? 2 over 3. Now, what you just find is either orange or blue. So to get neither orange or blue, you are going to use the complement rule. 1 minus either of them. You get neither. 1 minus either will give you neither. Do you get it? Neither. So 1 over 3. You see that you get same answer? You see that? Yes. So let's proceed. Let's look at the empirical probability and the addition rule. Now, according to the empirical rule, for them to find the probability of something, let's take this question. Antral Airways recently supplied the following information on their commuter flight from Accra to Kumasi. Now, to them, let me construct a table for that. To the empirical view, to find probability of an event occurring, let's say probability of arrival. To get a probability of early, first of all, you need to know the total frequency. That is the n. Okay. So the total frequency will be what? 100 plus 800, that's 900 plus this 975 plus this 1000. So total frequency is 1000. Now, to know the probability of those who come early, probability that the flight will be early, you come early, it should be the frequency. According to the empirical view, the formula should be frequency over n, where n means the sigma f, total frequency. So it should be the frequency of early, number of early, over what? Over total frequency, over 1000. You get it? Then on time will also be 800 over 1000. That's according to them, that's how they find it. It's just the frequency over total frequency. Okay, so if you have a frequency distribution table and you want to find probability of something, just take the frequency over total frequency. And it's still the same way for finding relative frequency. Okay, so this will be 75. The probability of late will be 75 over 1000. Are you following? And the probability of cancelled will be what? 25 over 1000. 25 over 1000. You take the frequency divided by total frequency. Exactly. That's how to find their probabilities. But the question is asking us that what is the probability that a flight will arrive early or late? So this one too wants you to use the addition rule. Okay, or its addition. Now, which addition rule are we going to use? Are we going to use this one or this? Now you should know that we are going to use this. The reason is that there is no situation, this mutually exclusive event. There is no one who arrived early and late at the same time, or there is no one who arrived early and on time at the same time. Is there anything like that in the table? Is there any situation where some people arrive late at the same time early? No. So since there is no such situation, you are just going to add their probabilities. You won't subtract any intersection. Do you get it? So the probability of early or late should be what? What's the probability of early? 100 over 1000, isn't it? 100 over 1000 plus, what's the probability of late? 75 over 1000. So you add probability of early plus probability of late. When you add them together, you get what? 175 over 1000. 175 over 1000. So you can convert it to decimal. It gives you what? 0.175 or so. Yeah. So the probability that a flight will arrive early or late is 175 over 1000. Do you get it? Yeah. You just add the probability of early plus probability of late. You are not going to subtract intersection because there's no intersection. There's no situation where some people arrive early and late at the same time. There's no case like that. No. Do you get it? So you just add. Then question 2 says that what is the probability that a flight will arrive late or on time? So here too, you are going to add the probability of late plus the probability of on time. Okay, so 75 over 1000 plus 800 over 1000. Do you get it? So that gives you what? 875 over 1000. That's 0.875. 875 over 1000. Are you following? 875 over 1000. So that's the probability that a flight will arrive late or on time. So I can ask you to find the probability that a flight will be cancelled or late. So that one will be 25 over 1000 plus 75 over 1000. You are not going to subtract intersection from here because there is no intersection. Intersection is 0. There's no case where somebody arrived early and late at the same time, or on time and late at the same time, or cancelled and late at the same time. No. Do you get it? Now, another question. In a hospital unit, there are 8 nurses and 7 physicians. 7 nurses and 3 physicians are female. Hello. Find a probability that a staff is a nurse or a female. So which of the addition rule are we going to use here? Look at something. 8 nurses and 7 physicians. Are you getting it? 7 nurses and 3 physicians are female. Meaning 7 of these 8 nurses are female and the remainder 1 is a male. And this also says 3 physicians are female. So 3 of these 7 physicians are female and the rest of the 4 will be what? Male. Do you get it? So there are cases. Look at, find a probability of a nurse or a male. Meaning there is a case where somebody is a nurse at the same time a male, isn't it? We have one nurse which is a male at the same time. It's a nurse and a male at the same time. So we are going to use the one that you subtract intersection from. Now to make this simple for you to do, you construct a table. When you see a question that looks like this, in order not to confuse yourself, what you do is that you write nurse here, nurse, okay, then write physicians here, physician, then here you write male, okay, then write female. You can write the female first before the male, it doesn't matter. Then you find total here, total, okay, then you also construct another total here. I'll tell you the reason why you are constructing another total here, total, another total to here. Now what's the total number of nurses? We have 8 nurses in general, isn't it? So nurses, this nurse, nurses, total of nurses is 8 in general. What's the total number of physicians? Physicians in general is 7. Are you following? Are you getting it? So now it says 7 nurses and 3 physicians are female. So for female, 7 nurses, see nurses, 7 of them are female. Are you following? Then physicians, 3 of the physicians, these physicians, no, 3 of them are female. Do you get it? So if 7 nurses are female, meaning the remainder 1 is a male. If 3 physicians of the 7 physicians are female, meaning the remainder 4 are male. So the remainder 4 of the physicians are male. Do you get it? Yeah. So to know the total number of people in general, like all the nurses plus all the physicians, whether you are a male or a female, general is 8 over what? 7, which is 15. Are you following? Then, to know the reason why I wrote this total is that we can also find total number of male, total number of female, irrespective of whether you are a nurse or a physician. Total number of male in general is 5, irrespective of your occupation, irrespective of your position. Total number of male is 5. Total number of female is what? 10. Do you get it? So 5 plus 10 is also 15. Have you seen that? Yeah. So you construct this simple contingent table to make your work simple. Now, to solve this question, so we say we are going to say probability of what? Nurse plus probability of male minus probability of nurse intersection male, isn't it? Isn't it? We are going to use the first addition rule, the general addition rule. Okay. So what's the probability of being a nurse? Probability of a nurse will be what? See, probability that the staff is a nurse, just nurse, okay, should be number of nurses in general over what? Total number of people. Do you get it? So what's the total number of nurses in general? 8. Do you get it? 8 over what? What's the total number of people? 15. Are you following? Plus, what's the probability that the person is a male? To get a probability that the person is a male, it means total number of what? Male in general, which is what? Which is 5. Do you get it? Total number of male in general, which is what? Which is 5. Are you following? Over total number of people, which is what? 15. It should always be over the general total. Do you get it? Minus the intersection. What will be the intersection? How many people are nurses at the same time male? That's the intersection we are talking about. It's 1. One person is a nurse at the same time a male. Do you get it? Nurse male. So 1. So minus the intersection, 1 over 15. Do you get it? So 8 over 15 plus 5 over 15 minus 1 over 15 should give you 12 over 15. If you simplify 12 over 15, 3 goes into 12 4 times and goes into 15 5 times. That's 4 over 5. If you put this on your calculator, it will give you the answer straight, 4 over 5. So the answer to A is 4 over 5. Let's solve B. B says a physician or a female. So we are going to say number of probability of physicians plus probability of female minus probability of physician intersection female, isn't it? So what's the probability of physicians? Meaning total number of physicians, which is 7, over sample space, which is 15. Plus, what's the probability of female selection? It will be total number of females, which is 10, over general total, which is 15. Then what is the intersection? The intersection is what? Physician intersection female, meaning those who are physicians at the same time female, there are 3 numbers. So minus the intersection, the probability of that intersection. So 3 over 15. So 7 over 15 plus 10 over 15 minus 3 over 15 gives you 14 over what? Over 15. In probability, the numerator is always smaller than the denominator. So the answer for B is 14 over 15. If your possible answers, this thing can be given to you in MCQs. I just put it like this. You can say use this to answer question 38 and 39. Then 38 will be like, what's the probability of a nurse or a female? 39 will be like, what's the probability of a physician or a female? Okay, so you answer in that accord. If the possible answers are in fraction, then you leave your answer in fraction and choose the correct answer. If the possible answers are in decimal, just convert your fraction to a decimal, then you go. So let's take another question. This question is coming from multiplication rule. It said the probability that a particular knee surgery is successful is 0.85. If 3 knee surgeries are conducted, what is the probability that A, all the 3 knee surgeries are successful? So to solve A, okay, the probability that all the 3 knee surgeries are successful is that the probability that the first one is successful, okay, and means multiplication, the second one too is successful, okay, the second one too is successful, okay, and that's multiplication, the third one too is successful, the third one too is successful. Do you get it? The first one is successful, the second one is successful, and the third one is successful. Hello? They say all 3 knee surgeries are successful. If 3 knee surgeries are conducted, what's the probability that all the 3 are successful? So meaning the first one is successful, and the second one is successful, and the third one is successful. It won't be all. If you say all, it means that it's only maybe either of them that is successful. If you say, oh, the first one is successful, or the second one is successful, or the third one is successful, you are not saying all the 3. Do you get it? But if you say and, it means all the 3 are successful. Do you get it? So and means multiplication. So to answer A, the probability that the first one is successful is 0.85. Isn't it? And the second one also is successful is 0.85. Are you following? And that's times. The third one is successful is also what? 0.85. So you multiply them. Okay. Kindly take your calculator. 0.85 times 0.85 times 0.85. It gives you 0.614125. But you only leave your answer in 3 decimal places. Okay. 0.614. So the answer to A is 0.614. Then B is saying that what's the probability that none of them is successful? Now, before you can find this, you need to know the probability that one is not successful. And that's what will lead us to complement. Now, there's something in probability we call complementary rules or complement. Okay. Now, the complement rule states that, okay, the complementary event rule states that probability of an event occurring, E, okay, plus probability that an event will not occur. Before we can solve B, you need to know this. Probability that event E will occur plus the probability that event E will not occur should be equal to 1. Okay. And this meaning probability that it will rain tomorrow plus probability that it will not rain tomorrow is equal to 1. Do you get it? Yeah. And when you make probability that the event, let's say this is success and this is failure. When you make probability of success the subject, okay, when you make probability of success the subject, let's assume E is a success and E hat is a failure. If you make probability of success the subject, you get 1 minus probability of failure. Are you following? You get 1 minus probability of failure. Meaning this comes here. If you also make probability of failure the subject, you also get same 1 minus probability of success. So you have to know this rule, okay, that if the probability that it will rain tomorrow is 0.2, if I say, oh, the probability that it will rain tomorrow is 0.2, then the probability that it will not rain tomorrow will be 1 minus 0.2, that's 0.8. Do you get it? Yeah. So you are going to apply that here. What is the probability that one knee surgery will not be successful? It will be 1 minus what? 0.85, isn't it? And that gives you 0.15, isn't it? But they are saying all the 3 are not successful. So if all the 3 are not successful, meaning the first one is not successful, which is 0.15, and the second one too is not successful, which is also 0.15, and the third one is not successful, which is also 0.15. Hello? I'm saying that the probability that one is successful is 0.855. So the probability that that one will not be successful should be 1 minus the success. That's why I brought you to this. The probability that something will not be successful will be 1 minus the success. So if 0.85 is success, then failure will be what? 0.15. That's 1 minus success will give you 0.15. So we have, but B, we want to find none of the three is successful, meaning all the three are not successful. So meaning the first one is not successful, and the second one is not successful, and the third is not successful. Okay, so when you do the 0.15 times 0.15 times 0.15, that gives you what? 0.003. Okay, that gives you 0.003. Then the third one says at least one surgery is successful. To get at least one, probability of at least one, okay, at least one should be equal to one, a whole number 1, okay, whole number 1 minus, okay, probability that none is successful. You get at least one. Okay, 1 minus probability of none will give you at least 1. Okay, whenever you say at least 1, if you use the formula 1 minus probability of none, you get at least 1. So 1 minus, what's the probability that none is successful? Is it not 0.003? We already know that one. Okay, so 1 minus 0.003 gives you what? 0.9 what? 997, right? 0.997. So that's the answer to this. Okay, now for this, it said a box contains 3 red balls, 2 blue balls, and 5 white balls. A ball is selected and its color noted. Then it is replaced. Hello? It is what? Replaced. This is replaced. Oh. Okay, it is replaced. So you still have equal chance of selection. The sample space does not change. It is because it is replaced. Now, a second ball is selected and its color noted. Find the probability that find the probability of each of A, selecting 2 blue balls, B, selecting 1 blue ball and 1 white ball, and C, selecting 1 red ball and 1 blue ball. To answer this, A, we say what? 3 blue and 3 red, 2 blue and 5 white. So in total we have 10 balls in total. Okay. Now, the probability of selecting a red ball will be what? 3 over 10, isn't it? The probability of selecting a blue ball will be 2, number of blue balls over total number of balls, 2 over 10. And the probability of selecting a white ball will be what? 5 over 10, isn't it? Now, the question is asking that, what is the probability of selecting 2 blue balls? Meaning, the first one is blue, so the probability that the first one is blue is 2 over 10, isn't it? Sorry, 3 over 10. There are 3 blue balls. 3 over 10. Sorry. 2 blue balls, okay. So 2 over 10. And that's times. The probability that the second one is also a blue ball is also 2 over 10. So 2 over 10 times 2 over 10. Do you get it? Okay, it is replaced. If the question I said it is not replaced, then it will be 2 over 10 times 1 over 9. We'll come to that one later. Okay, so it is replaced. So you still have equal chance of selection since it is replaced. So the probability of selecting a blue ball first is 2 over 10. And the probability of selecting a blue ball second is also 2 over 10. So it's 2 over 10 times 2 over 10. That gives you 4 over 100. So in decimal is 0.04, right? 4 over 100. So you've answered A. Then B. What's the probability of selecting 1 blue ball and then 1 white ball? So probability of selecting 1 blue ball. What is the probability of selecting blue ball? Is it not 2 over 10? Yeah. Number of blue balls over number of balls. And 1 white ball. What's the probability of selecting white ball? It's what? 5 over 10. Number of white balls over total number of balls. Okay, so 5 over 10. Do you get it? So 2 over 10 times 5 over 10 gives you what? That's 2 times 5, 25, 10 times 10, 100. 2 times 5, 10. Sorry, my mind is on 5 times 5. 2 times 5, 10 over 10 times 10, 100. So that gives you 10 over 100. And 10 over 100 is the same as 1 over 10. Okay, or 0.1. Okay, 1 over 10. In decimal is 0.1. Okay, so let's go to the last one. Selecting one red ball and one blue ball. If you select one red ball and one blue ball, what's the probability of selecting a red ball? The probability of selecting a red ball is what? Number of red balls over total number of balls, isn't it? Times, what's the probability of selecting a blue ball? Sorry, a blue ball, yeah. That's 2 number of blue balls over number of balls, 2 over 10. And that gives you what? 6 over what? Over 100. 3 times 2 over 10 times 10, 6 over 100. That's 0.06. Is that clear? Yeah. That is the end of this lesson. Okay. That's the end of this lesson. And kindly rewatch the video. If there's any question to ask, you can feel free to drop it in the comment box, or you ask that on WhatsApp. Okay. Thanks for watching.